Okay. Yeah, we're 2 minutes past, so looks like most everybody has shown up. So yeah, let's go ahead and kick it off.
Okay, let's jump into it. Let's go right into introductions. I am Tate Brown. I'm an additive manufacturing applications engineer for Go Engineer, and Chris Wilson is also a panelist on this, and he's your digital manufacturing sales representative. Some of you were, most of you were probably invited by Chris. Others of you may have been invited uh, by another rep. But let's jump straight into this. So what we're going to be talking about today is the F-123 series and kind of what's new. If you've been following along with the F-123 series, you'll note that some of this isn't extremely new, but this whole series of machines is the newest thing on the FDM line for Stratasys. So let's get going in the slideshow here. Let me hurry and start out with telling you our mission. Go Engineer provides design and manufacturing tools with expertise that enable customers to reduce the cost, risk, and time required to go live with new technologies and ultimately new product introductions. Who we are is experienced experts. So 40% of our employees are certified technical specialists, meaning that we have taken the time to actually get certified. And if you think about 40% of a company, you'll note that 40% of any company is not applications engineers. So more than just our AEs are certified and specialists in the products. That's why we're trusted partners with 95% of our customers are doing repeat business with us, and we are industry leaders with both SolidWorks and Stratasys equipment. We have local and nationwide offices, and you can see on this map we've kind of made an eastward expansion, but we like to keep that local feel. So our technical support is going to be close to you. We're expanding constantly, and if you're not in one of our really close to one of our offices, it may not be long until you are. We offer 3D printing with all of our 3D printing training with all of our 3D printers, as well as additional training post-sale if it's necessary. There are times when you may need to print a part out of a material that you don't have, or a build volume that's just way outside of your range. Say you already have a printer, but you don't have a printer that will do a certain part. We offer the full Stratasys line of printers as an option to you as a service bureau. And by the way, I should also say, feel free to use the Q&A feature. Chris is a host on this webinar with me, and he's going to try and field any questions you might have live. Also, I'm going to provide some PDFs, and Chris may actually send those out after this. He'll follow up and send you the PDFs that I used as sources for this PowerPoint. So what we're going to go over is why 3D printing is important. Just a quick introduction. Most of you already know, but it's still important to go over. What many of you may not know is why industrial grade is so important versus a hobby level system. And then specifically, we're going to go over speed and hardware improvements on the F-123 series. And once we kind of show you how these machines are built, we're going to show you the lineup of the 4 machines in the F-123 series. There are some new materials that are available in this series, so we're going to go over that as well. And software improvements. I'm going to do a live demo at the end just to kind of show you, if you're not familiar with our slicer, GrabCad is what we use for Stratasys machines, as well as Insight. We'll go over mostly GrabCad in the live demo. So 3D printing is a great manufacturing process because engineering or manufacturing background is no longer required. So that means there's little to no training necessary, and these are office friendly, basically manufacturing centers. This promotes collaboration within your organization just mainly through its ease of use and because of its cost effectiveness. 3D printing has totally hit the mainstream by now. 80% of enterprises report that 3D printing is enabling them to innovate faster. 51% of those enterprises are actively using 3D printing in production, and 70% of those enterprises found new applications for 3D printing in the last year. So what that means is once you have one of these printers, you're just going to keep finding new ways to utilize it. And that happens year after year after year. And having these new materials and these new hardware upgrades and software upgrades help enable additional uses as well. One of my favorite parts about 3D printing is the fact we're able to go paperless, and not just because it's environmentally friendly, but if you've dealt with 2D drawings ever, you know that they can have errors from time to time or just a missed dimension. I actually used to create 2D drawings for a company, and I will be honest, I have left out a dimension before, and it caused a total delay. So in a fast-paced company, it might only put you behind schedule by a day to have a missing dimension, because that shop now needs that dimension. They've got to bark it up through the chain. You've got to reprint drawings, fix them, resubmit them. Eliminating this with a digital format like an STL file is fantastic. Now we don't spend time creating instruction for production. Now we can basically take the design straight from CAD, send it to the printer, and get what we want. Another cool thing about 3D printing is it's lights out on day one. So lights out is a CNC world term that basically just means we're operating unmanned. So now you're able to, maybe you finish designing a part by the end of the day, you can hit print and come back in the morning and have that part finished and ready to go. So you can see in this little video, that's a pretty complex assembly. Trying to traditionally manufacture the pieces in that assembly would be extremely time consuming, difficult, where with 3D printing, complexity is totally free. And what I mean by that is if you were to say machine a block of cheese out of billet aluminum, that would take next to nothing. You know, you've got to surface it and that's it. But say it was a block of Swiss cheese. That just throws you for a total loop because there are voids all over and pockets all over. That would be a part that would be unmanufacturable without additive technology. So now we're able to print an unmanufacturable part, but not only was it unmanufacturable, it also is going to print quicker because it uses less material, and it's going to be cheaper because it uses less material. That's less area that the print head has to cover. So if you look at this next slide, that hopefully isn't a familiar sight to you on the left, but why go industrial? If you've seen that before, you know why already. This picture definitely isn't meaningless, and it doesn't come without some emotion looking at a print like that, because you've wasted a ton of material. You put some of your heart into that, and when you come back and you see that your print head's destroyed because of a clogged extruder, it's a heartbreaker. So the main reliability issues we have with hobby level systems are clogged extruders, warped parts. That's mainly due to the way they cool and heat the material as it's being printed out. Stringing and oozing, these are highly technical terms. you have my permission to use them later, and layer misalignments. So this is where the machine can't keep consistent X and Y alignment as it prints from layer to layer, and you can actually end up with kind of a stepped surface in your end product. So the benefit to industrial grade printing is that we've eliminated or reduced those happenings. Excuse me, sorry, I accidentally switched a slide too early. So the major benefits are your throughput is increased tremendously because we're able to print at a much higher rate with a much lower lost part rate. So that's going to increase your speed to market and allow you more iterations per design cycle. Designers and engineers alike value more iterations. I mean, we always want to make a better part. So a lot of times I'm always thinking, man, if I just had one more iteration of that part, we could have made it so much better. Well, with industrial 3D printing, you're able to reuse some of those time savings toward more iterations. The other is you get a more accurate part, so you have a reduction in the number of secondary processes, and again, overall better reliability. So this is important because you don't have to have a tech guy that's dedicated to your hobby level system. An industrial grade system should be able to operate with anybody in the office. So now no longer do you have to fiddle with parts and tuning and getting everything just right for a specific material and then just changing materials later. And then lastly, the reason to go industrial is because of the array of materials that are offered to you on an industrial grade system. It just opens up tons of ability to print new parts, and it helps tremendously. So this next slide are basically my highlight reel of why these improvements are so important and the improvements that really matter to us as end users. So one being our new formulation of ABS is called ABS M30. Our legacy ABS was called ABS Plus. So now our the cost per cubic inch of the ABS Plus was about $4.50, a little bit over $4.50 per cubic inch. And now we're down below $3 per cubic inch with the new ABS M30. That's huge because cost savings are always good, no matter if you're a user or the owner of the company. Also, another upgrade is we have USB ports and Wi-Fi capability, as well as the standard Ethernet capability that we had in the past. Head replacements are no longer a tech visit type of situation. You don't have to have a professional service tech at your facility in order to change heads anymore. It's a do-it-yourself project now. And I think it's actually really comparable to just changing out an inkjet cartridge on your normal paper printer. The addition of servo motors has improved our speed and accuracy, and now we have larger spools, so we're able to run these machines for longer without changing over materials. And then lastly, we have reusable build sheets. So something from the past machines, our legacy machines, I keep referencing, those were actually a consumable. They're still technically a consumable on these new machines, but they're going to last multiple builds without problems. So here I just have a quick 2.5-minute video. This is going to explain the anatomy of the F-120 specifically, but this is going to trickle throughout the whole F-123 series. Don't feel like you need to take notes of any of the highlights or anything. This is going to be included in PDF form afterward. Okay, so that was jam packed full of information. Um, if you guys want, I can send that video in that email, the follow up email with Chris as well. Just let us know in the chat. So again, without referencing a competitor's machine, we'll just reference one of our legacy machines to show some of the improvement that we've had with this new F-123 series. So this is an identical assembly printed on both a Uprint SE Plus, a legacy system, and the new Stratasys F370. The print time on the SE Plus was 7 hours and 18 minutes, and the material cost was just under $50. On the F370, we're able to almost cut the time in half with a 48% time savings and a 36% cost savings. Where the cost savings comes from, again, is with that ABS material being so much more affordable on the F123 series. And where the time savings come from, I don't know if you guys can see that little bow tie looking artifact or part on the tray of the F370, but that's actually a sacrificial material tower. And we call it a bow tie, but basically what it is it reduces the head movement of having to have like a purge bucket in the back of the machine where the head used to go from the front or from the build area to the back of the machine and purge material into the bucket, then come back to the part. Now we've moved that same process to a more controlled process and closer to the part. So with the reduced head movement, we actually increase the build time as well as the part quality. So your seams are a little bit less visible, and you're just going to have overall better consistency with that sacrificial tower. So let's jump right into the machines here. We're going to start from the bottom and move our way up. Most of the systems operate with the similar hardware, and so you're going to see a few changes as we continually step up the product line. So we start out with the F-120, which has 1,000 cubic inch build volume, which is totally symmetrical. It's cubic, and it is going to be able to print some fairly large parts. The finest resolution, which I know that's kind of a hot button for folks, is a 7 thousandths layer thickness, which is pretty respectable. And you'll see it's a desktop style system, and these two boxes underneath are for your material spools. These are, again, office friendly, super quiet. They plug into a normal wall outlet, and you're talking 46 decibels. So that's a pretty quiet machine. If you look on the right side of your screen, you'll see the material that Stratasys offers, and the emboldened text is what's available on this machine. So you have access to the ABS M30, which is a fantastic all-around prototyping filament, and you have access to ASA, which is one of my favorite materials just because of its overall usability and UV stable properties. We'll jump straight into the F-170. Same build tray and build volume, but you get the addition of a 5 thousandths layer thickness, as well as our standard spools come in a 60 cubic inch spool and a 90 cubic inch spool. So that offers two spool areas in this system are contained within the system. It's no longer a desktop style. And you're going to have one spool for model, one spool for support. You also see with the F-170, you get the addition of having the TPU 92A shore hardness material available. That's kind of like a rubber-like material. It's flexible and can be used in a lot of different situations. You also get the addition of PLA. Some of you might wonder why you'd use PLA with a industrial grade printer. That's definitely a popular option for a hobby level system. We like it just because of its cost effectiveness. It does have decent mechanical properties, but it's mostly there for cost effectiveness. Moving into the F-270, you see pretty much the only thing we changed as far as looks was just the number. The actual plate here is the F-270. The build envelope also increases, even though the exterior of the product looks the same as the F-170. We do add an additional 2 inches in the X and 2 inches in the Z. You still get all the layer thickness options. You have 2 additional bays though with the F-270. So you get 2 model bays and you get 2 support bays for an overall additional four bays. Same materials is available as on the F-170. And then finally, we move into our flagship model, the F-370. So one of the big highlights here is we almost double our build volume in cubic inches over the F-120, which already has a generous build volume size. We, again, have 2 model, 2 support bays. It's still a super quiet machine, 46 decibel max. And then my favorite part of all is the additional materials that come on the F-370. New to the F-370 is the ABS ESD7 material, which is an electrostatic dissipative material with ABS properties. And you also get the addition of PCABS on the F-370 and an F-370 exclusive, meaning this isn't even offered on our highest end printer, Duran 410. So that's a great option, and we're going to go into some of the characteristics of those new materials here in just a second. Just to note though, all of these materials are new on our systems versus the legacy systems. The only one that's going to be similar is the ABS M30 is going to be similar mechanical properties wise to the ABS Plus. So I want to introduce the ABS ESD7. Again, this is a static dissipative ABS thermoplastic. Its properties are due to the fact that we infuse carbon nanotubes into the filament, making it so it's less shock resistant. This is a cost-effective alternative because it replaces metal fixtures, plated fixtures. It also just saves time overall, which is a huge cost waste. It has the same characteristics as ABS, so you have some familiarity there, and it doesn't attract dust or fine particles, which in some scenarios is super important. Again, just highlighting some of the benefits of the ABS ESD7. It does come with our soluble support, so you can do complex geometries with easy post-processing. And then the last material I want to kind of go over more in depth is the Duran. Again, this is exclusive to the F-370. This is a really cool material. It's a nylon-based material specifically formulated for the production of jigs, fixtures, and manufacturing aids, and really whatever you can think of. The reason it's such a great material is because it has excellent mechanical properties and toughness. So it's a great option for the shop floor because this can be dropped without cracking. It also has excellent low scratch and non-marring characteristics. So this limits damage when it's in contact with something that might have a kind of more finicky surface finish. And the overall properties, we can get you a data sheet on this as well so that you can compare it to other materials, are just phenomenal. Again, we limit damage to sensitive components just because of its mar characteristics. This can also be used as kind of a wear component because of its lubricity. It's one of the most lubricious materials that we have, and that's due to some mineral additives into the nylon-based material. And then lastly, I just want to move into some of the notable software developments and what they've done for us. So all of these kind of hardware improvements that you've seen through the anatomy and build up have essentially enabled us to create builds faster and increase our throughput. Not only that, but we print faster and the quality is improved. The reliability is improved. So it's kind of a double-edged sword. We have easier to operate user interfaces with GrabCAD versus other slicers. We know that other slicers are improving as well, but GrabCAD is honestly, as a multi slicer user, because I do still use hobby level systems for fun sometimes, GrabCAD is my favorite slicer that I've used to date. One cool feature with our flagship model, the F-370, is it comes with the ability to use Insight software. So for any of our Stratasys users that already have machines and have used Insight, you understand that it's a very powerful software, and the ability to use it on one of these machines is just a great addition. However, GrabCAD still offers advanced FDM for added control. So some of the features that you can do on Insight, you're also able to do with GrabCAD, just in a little bit different way. Instead of working at the slice layer with Insight, with GrabCAD, we're working with features, which is what most of us are used to if we've used CAD in the past. So I just want to do a quick live demo of GrabCAD here really quickly. And I just need to hurry and change my screen over. Chris, are you getting any questions?
Just a couple. I've been fielding them as they come in, but
Cool.
yeah, if anybody's got questions on the printers, shoot them my way.
All right, so this is the UI of GrabCAD, and you can see it's super accurate. So this is what the build tray, and it actually outlines the build volume. Are you guys able to see that okay?
Yeah.
I know sometimes the lines are hard to see on webinars of the build volume, but basically this gives you a good idea. This is a vise jaw that I've created, and it's pretty large. So you can see the build volume is really huge on the F-370. That's not necessarily what I wanted to show off though. So let's go to a new print project. And I just want to show kind of how quick and fast this works. It loads models up really quickly. It works with native files. So this is a native SolidWorks file that I just loaded in. You can see the sacrificial purge tower here. And you basically just walk through the system here on the right side, and you can select your materials as well as the build style. You can get more into this later. Infill style, this is something that you've probably dealt with in the past with other slicers. And just the main support options and settings, it's all here just like a normal slicer. However, it's just really cleanly laid out and easy to use. Slicing, it's relatively quick. I've worked with other softwares that are significantly slower to slice, and it produces graphics very, very quickly. So here we're able to see at the slice layer exactly what's going on in terms of the build. We can see the support and model material. But say I want to do some more advanced work. I can go up here to File and the new Advanced FDM project. And this is actually new. If you're already working with GrabCAD, I suggest you update, because you're now able to work with native CAD files in Advanced FDM, where in the past it was just STLs. So with this, I want to show you kind of how it works based on features instead of at the slice layer. So say, for example, if I slice this normally, so I'll enter the slice preview here. and I'm just going off of kind of defaults that it's already set up with. It's going to build supports in for these holes to try and keep those circles round. And if I don't like the view here, I can go to my favorite view is up to layer, because it mimics more of what the printer actually looks like as it's building. But you can see that support's being built into those features. Well, say I don't want that support there because these holes might be super critical that they be dimensionally accurate. Oftentimes, even with an industrial grade printer, you can end up with a slight ovaling of these holes. So say they are critical and I don't want support in there anymore. Let's exit this slice preview here. And let's make these holes self-supporting. I can do that just by selecting these two surfaces. I can hold Shift to select them both and check the box for make self-supporting. I update it and you can see exactly why they're self-supporting now. They've basically just created diamonds. And what these are they're just going to be hole centers for your drill bit when you go to post-process this by drilling a hole to an accurate dimension. So when you have supercritical holes or features, now you're able to make adjustments to those in advanced FDM based on the feature rather than having to adjust just on slice levels. So what this does is it gives you the capability to not just make adjustments in the Z layer. So a hole like this would only be adjustable if it were laid down flat in Insight. Now we can stand it up and make adjustments to these holes, and they'll show through because of our feature recognition. Anyways, that's all for today. Probably give you the last slide here, end on the last slide so you guys have some of our information. So thanks for joining. If you stayed with us the whole time, I really appreciate it, even if you just took a minute out of your day. We enjoyed having you here. If you have any more questions, feel free to hit me or Chris up. He's going to provide some more information. I like to think of it as the tech info for nerds. We're going to send you that, and it's basically all the information I use to kind of create this highlight reel. But I honestly really love that information. So I'll get that over to Chris, and he'll send it out here today. You think you can get that done, Chris?
Absolutely.
Cool. I guess we'll stay on for, if anybody's still around and wants to ask a live question, feel free.
But a couple of questions come in regarding
cool.
the software, but yeah, but we've been answering a lot of those as they come in. So yeah, like Tate said, I'll email everybody this information, and it'll have my contact info as well as Tate's. So feel free to reply back to us. And again, appreciate your time.
Thanks a lot, guys. Have a great day, and hopefully we hear from you soon.
Thank you.